All right. So, ladies and gentlemen, good to have you here today. We got 5 people watching so far, so we're just gonna wait around 3 minutes for more people to show up. Once we got more people to show up, we're gonna get started. Today's lesson, I'd say is on the shorter end, mainly because it's more of the math now, like actually just solving and learning about laws. So if you know about exponential laws, and if you didn't take too long to learn about exponential laws, this one should be fairly quick, in my opinion. So I don't think it will be too bad. Yeah. So we're gonna wait around 3-4 minutes, and then we'll get started. So if you have any questions or you want to chat, feel free to type, and we'll talk. Let's talk. Alright, we got 6 people in. Just gonna wait a couple more minutes and then we'll get started. The worksheet you should have open now is this one here. It's coming up on the screen. It should have laws of logarithms here. If you don't have this printed out, you have it ready. You can start copying down the questions so that if you don't have it printed, you can start writing. If you have it printed, that's great. We're just gonna wait and see. Well, hope everyone's having a wonderful day so far, and hopefully this is just the end to your day. I think it's a pretty nice day outside. I'm hoping to get a run in later with some friends. Hopefully you guys are going out every now and then with social distancing to get some vitamin D, not being a shut-in and not getting that vitamin D. Yes, the weather is fantastic. If you just take away the rain, the temperature's finally like settling at a very comfortable, comfortable temperature at around like what, between 15 to 20. That's like perfect for me. I love that temperature. That's fantastic. Okay, we got 9 people in. Let's just get started. I don't want to take too long. It should be like 20-30 minutes max. So let's just get started with this. Okay, laws of logarithms. So reviewing what we did yesterday, right? So when we talked about logarithms yesterday, we essentially talked about how to convert from exponential form to logarithmic form, as well as the 3 basic properties, right? Log base a of a to a power is just the power. A to the power of log base of a to something is also just the power, and log base of a to 0 is 1, right? Because anything to an exponent of 0 is 1. Log base a of 1 is 0. And so as a result, right, we're adding on more things. So let's look at each of these laws and then we'll see how to use each and every one of them. So product law number 1, log base a, where a is any number, of xy, where x and y are any numbers, is equivalent to log base a of x and plus log base a of y. So this is the product law, which is the multiplication. When you have two parts multiplying inside a logarithm, you can separate them into addition and vice versa. Okay, so that's the first law, which means, of course, if there's a product law, there is a quotient law. There's always the opposite, right? If there's an addition law, there's a subtraction law. So for quotient, if two things are dividing within a logarithm of base a, you can subtract the two from each other. Now, the main thing you have to understand about this is that the base must stay consistent. Notice how the base in all three of these logarithms are all a. If the bases are different, you cannot use this law. And I've seen teachers do it where they put like base 2 and then base 3, and then it screws someone over completely. They're like, oh yeah, quotient rule, I can do that. And then they get it wrong. Try not to do that. Try to point out, yes, confirm that the bases are the same, then use the law. Okay. The power law is pretty simple. Log base a of a power and to the exponent. That exponent comes out to the front as a coefficient of the logarithmic function. Right? So the r just pops down to the front, and that's it. So very simple. And then change of base. This formula is very, very unique. When someone asked me, once again, I'm going back to that review class, someone asked me, hey, can we calculate base like 2, base 3 on a calculator? I said no. You can't do base 2 and base 3 on a calculator. What you can do is base 10. So what this allows you to do is if you have a certain base a of x, then you can convert and solve it by using a different base b. And for us, if we're doing it on a calculator, we can change that to base 10. And now we are able to approximate what that logarithm is at a certain base. So now we have the tools. Now we can solve, right? So before, no, you can't do just base 2 or base 3 on a calculator. So now I'm adding on and saying, now you can, but it's in a very roundabout way by using the change of base law. Okay? So let's use each of these laws. First one here, log base 3 of 6 plus log base 3 4.5. We know that that must be the product law because we see the addition sign here in the middle. And we can confirm that the bases are the same. The bases are both 3. If that is the case, then we can write log base 3, and we can basically combine and say that's 6 times 4.5. Like that. And in doing so, when you do log base 3 of 6 times 4.5, you can solve that, and that gives me 27. And there we have it. And it's not asking you to solve it, but if you can solve it, you keep going. Can base 27 be written in terms of base 3? And the answer is yes. You can keep going. So you're not done simplifying. If you stop here, you're missing one last mark. And so you can change it to this. Log of base 3 to 3 to the power of 3, which equals 3. And there's your final answer. I'm just going to draw a line here so we don't cross over. Right? So this is the base property. And we said log base 3, and if there's a 3 and the bases match, the exponent is the answer. So we have that. Let's go to our second rule. Log base 2 of 48 minus log base 2 3. We can confirm both bases are the same. It's subtraction, so we know it's the quotient law as written above here. So we can go right into it. Log base 2 of 48. The left number goes on top, the right number goes on bottom, like such. So log base 2 of 48 over 3. That will give me log base 2 of 16. And then that would give me log base 2 of 2 to the power of 4, which gives me the answer of 4. Once again, the bases match, so the exponent is your answer. And I think people are starting to get used to it, and I think they're starting to understand how this is working. So there we have it. Next question, part C. This one here, we change our roots back to exponents first. So we can change our cubic root into an exponent, which is 1 over 3. So we're going to get log base 5 of 25 to the power of 1 over 3. Now we're going to use the power law. If we have a power, we can bring it to the front of our logarithmic function. So we can do 1 over 3 log base 5 of 25. So this is what we have now. We've moved our exponent down to the front. We can now solve this base logarithm. So 1 over 3 log of 5 squared, which will give me 1 over 3 times 2, which is 2 over 3. And there's my final answer. So we're starting to apply these laws. So I'm going to explain this again. First thing I did, change the cubic root to 1 over 3 as an exponent. I used the power law. I brought the 1 over 3 down to the front of the logarithmic function. Step number 3, I changed 25 to base 5 to try to solve the logarithmic function. Once I did that, following the base property, since the bases match, the exponent is the answer. And then I multiplied by 1 over 3 at the front to get 2 over 3. Okay. So this next one here, log base 10 of 0.1 squared. We can put the 2 in front. And if it's base 10, you don't have to write anything. You can just go log of 0.1. And hopefully you know the log of 0.1 is -1. And so the answer is just -2. So that one's pretty simple. Are there any questions with this so far? Any questions at all? Okay. Let's go through a couple more questions here. So let's go through each of these, and then I'm going to give you some practice ones here. So here, log base 2, 2 root 2. We don't like 2 root 2. 2 root 2 is not nice. That is not very nice. But these are multiplying. It's 2 times square root of 2, which means we're now going to use our product law and separate it. We can separate it. If 2 root 2 is not nice and we can't solve that, we can separate it and say, no, I want to work with log 2 plus log base 2 of root 2. And there we have it. So that's going to give me 1 here plus 1/2 log 2, which is just 1 plus 1/2. And so that's 3 over 2. So if you're confused on how I went from here to here, root 2 is 1/2. I brought it to the front as an exponent. And log base 2 of 2 is 1. So 1 times 1/2 is 1/2. And adding these, I get 3 over 2. Okay. So there's that one. This next one here, I really hope you don't have any trouble with this. I'm just going to write the answer. That's -1. Very simple. Done. Next question. This one here. Little tricky. Little tricky. You can solve this in a variety of different ways. You can solve it like terms. You can solve it by combining all of these and reversing the power law. There's a variety of different ways to do it. I'm going to show you two ways. Okay? So if you have enough space, try to fit it into two sections here. I'm going to try to solve the same question twice. The first method, combining like terms. So I'm actually not going to change the first one. I'm not going to change the second one. Oh, this is base 8. But I am going to change the last one here, right? And I'm going to change this to log of 2 to the power of 4. Okay? So I'm just changing the 16 to 2 to the power of 4. I'm going to bring the 4 in front. And my next line is going to be log base 8 of 2, 3 log base 8 of 2, and 2 log base 8 of 2. Now you'll notice a couple things. If this pen would start working. There we go. These three parts are the same. Log base 8 of 2 is constantly repeating, which means we can actually do like terms here. They're all the same logarithmic function. This can actually change. 1 plus 3 plus 2 is 6. So this is technically 6 log 2. 1 plus 3 plus 2 is 6. And then solving that out, right? Solving that out is going to give me, and reversing that is going to give me log base 8 of 2 to the power of 6. Right? And 2 to the power of 6 is 64. So log 8 of 64, and that we should know is 2. And there's our answer. Okay, so that's one way of doing it. That's collecting like terms. Another way you could do it instead is actually just reverse what's written here, and reversing the power law and then using the product law. So I'm going to do it the second time in black ink. So that was the first method. The second method, I'm actually going to set like this. So going from this top line to this one here, I've moved the coefficients in front of the log into my logarithmic function back as exponents. I am then going to solve it. So log base 8 of 2 plus log base 8 of 8 plus log base 8 of 4. Using our product rule, if you have more than one or more than two, you can just multiply things continuously as long as they all have the same base. So this becomes log base 8 of 2 times 8 times 4, which you should realize is log base 8 of 64, which we will get the same answer of 2. So there's our two ways of solving this question. Does it matter which way you solve it? No, math has multiple ways of getting the same answer. It is up to you which method you understand better. If you understand the first one, do the first one, collecting like terms. If you understand the second one better by converting it into your power rule and then your product rule, you can do that too, right? You're going to get the same answer. It doesn't matter which way you do it. Okay. Are there any questions about this before I move on? I felt like I was talking a little quick, but hopefully that made sense, and we can move on into the next few questions. So far, so clear. I like it, Daniel. Thank you. Thank you for the feedback. Anyone else? All right. So let's move on. It says write each expression as a single logarithm. So you're just combining it into one logarithm. So first one here, pretty simple. This is the product rule. So this is going to be 5 times 20. And so that's log base 10 of 100. And hopefully you know that the answer there is 2. Pretty simple. Let's do one more over here. Log base 2 of 1024 minus log base 2 of 512. These are big numbers. You don't want to figure out the powers, but we know that quotient rule exists. So log base 2 of 1024 divided by 512. And 1024 divided by 512 is 2. So log base 2 of 2 is 1. And there's our answer for that. So I'm going to give you 3 minutes, which is a lot of time in my opinion, to do these next 2 questions, C and D. You got 3 minutes. Good luck. All right. So let's check your answers here. So this one here, log base 5 of 5, log base 5 of 5, both are 1s. So we get -1 plus 2, which is just 1. So that one's pretty straightforward, as long as you were able to identify the base logarithmic property. So that equals 1. Absolutely. Very good. So I see Daniel and Fuad both got 1, which is fantastic. And hopefully the rest of you also have gotten 1. Now, if you do bring it up and you didn't realize that it was the base power function and then you did the product rule, you should still get the same answer. For question D, this one here. So combining all of these, right? You can definitely combine all of this together if you would like. And so I said one person, we have 2 different answers. So Daniel has a different answer from Fuad. So let's see if one of you are correct. If you have an answer, please type it in and then we'll check to see if it is correct. So we can see that all of the bases are the same here, so that's just fine. We have a 2 in front though, so we do have to keep that in mind. Okay? So that 2 log is very, very, very important. Now, depending on how you did this, it might change a little bit. But let's make our lives easier for us to use our our rules. So I'm actually going to do this. I'm going to put the exponent inside. And I'm going to do that. So that's going to give me, that's a to the power of 2. So that's going to give me log of 64 plus log of 9 minus log of 36. What that allows me to do now, since all the bases are the same, I can do the product rule and the quotient rule all at once. So the final fraction I get is actually 64 times 9 divided by 36. And I can kind of just combine all of that into one rule. So I've used the product rule to combine 64 times 9 and the quotient rule, which will allow me to just divide by 36. And so in doing that, I get log of 576 over 36. And I can simplify that by dividing it by 36. And I get log 10 of 16. And yes, it just asks for me to do it in a single logarithm. So technically log 10 of 16, I'm pretty much done. But if you did solve it into your decimal, then you should have gotten approximately 1.204. Okay, is that answer. Okay, so hopefully that made sense. So you wanna, if you can get it all into an exponent before you do the product rule, that's important. You can't really use product rule when there's a coefficient in front of your logarithm, because where's that going to go, right? So that becomes a little bit of an issue. Okay, so the only time that's even possible is if you are able to common factor it out, and then it's no longer an issue. So there are little things that you have to be aware of. And so that's why this question was a little bit harder. So if you got it wrong, that's okay. Now that you know your mistake, you've learned from it, and that's what matters as well. Okay. So there we have it. So we're just gonna go through a couple more examples, and you are 1 or 2 more examples, and you are free to do the rest as you wish. Okay. So this next question on the second page, it says use these properties to express each logarithm as log base a of x, log base a of y, and log base a of z. In other words, you are to separate these logarithms into its individual parts of the variables. So you're not solving anything, you're just expanding it. So for example, for the first one, it should be log base 6 x squared plus log base 6 y cubed. And since we want it in log base a of x and log base a of y only, we will simplify it further by bringing down the exponent. And now we have it written as log base a of x and log base a of y. And there we have it. So this is the practice that we're trying to use and trying to get to, so that I understand that you are able to use these product rules, these quotient rules, these power rules to convert from one thing to another. Right? And are you able to manipulate these logarithmic functions to be beneficial for you rather than detrimental? That's important, right? We want to learn math, and we want to learn these techniques to make your life easier, not harder. Okay? We're teaching you these techniques to make your life easier, not harder. And a lot of people think the other way. So for part B, separating it into its two parts, you would get, first, let's go step by step for this one. So root 4 of x minus log base 2 of y z. Okay. We can separate this further with the product rule. I separate, write that out already. So I'm going to go like this. That one I can write out. Then this next one, I'm going to write like this. Because this is the logarithm here, and because of the minus, I'm just putting a bracket there to indicate that that was containing this. I've separated it. And so my final answer can be simplified all the way down to here. And there's our full simplification of our answer. So you want to make sure that the only thing left in that logarithm is just the variable on its own. No exponent, nothing else. Right? That's the whole practice portion of this exercise. Okay? Sounds like my fire alarm's going off, but it's probably just a building check. So if you can hear it, just ignore it. So these last two questions, I'm going to give you to try on your own. I'm going to give you the answer. Okay? I'm going to give you the answer. Make sure that you are able to get to that point. Okay? So 1 second here. You can start working on it right now. I'm going to give you the answer. So the answer to the first one, your final answer should be 3 over 2 log a to the x plus log a to the y minus a half log a to z. That should be your first answer. Okay. Now for your second answer, you should get, from what it looks like here, your answer should be 3 log a to x plus a half log a to y minus 2 log a z. So that should be your answer for these two. Make sure you know and you can see how to get to these two answers. Don't just copy them and say, oh, I get it. I get how Mr. Choi did it. Don't do that. Actually solve it. Actually see if you can get your answers. And you'll see I have 2 pieces of homework at the bottom here on 2 separate pages, because part of the laws of logarithm is actually in chapter 7, and I'm doing a part of it now, which was the changing base rule. So we'll kind of go over that tomorrow as well. But yeah, that's the laws of logarithm. I think it wasn't too difficult of a concept to understand. So hopefully that was clear and easy to grasp. So for tomorrow, I will have your culminating assignment sheet prepared for you. So please tune in tomorrow to understand and hear the instructions for it. And I will allow you to do it with partners. So it can be individual assignment or group work. So you can choose that. And I would like to know during our session tomorrow who your partner is so I can write it down. So please, 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 please tune in tomorrow at 2 p.m. so we can get that all settled. If you know anyone who's not here, because we are missing almost half the class right now, please have them join us for our session tomorrow, because I do need to know who your partners are if you have partners. Second, tomorrow is also a tutorial day, so it should be like a 30-minute stream. If anyone has questions, they can ask me. If there are no questions after, then we just end the stream early, and I'll see you on Thursday. Okay? So that is it. Thank you so much for tuning in. If you have any questions, feel free to email me or tune into our stream tomorrow and ask me during our tutorial session. All right? Have a good rest of the day, everyone, and I'll see you tomorrow. Peace out.